Good morning. So let us start with the today's class. In previous class, we have studied how to draw the free body diagram for a given object, a given body lying on some different planes. Now let us start and apply the concept of free body diagram and solve the problems on friction. So starting with the reading of the question, it says that a body weighing 1000 Newton is lying on an horizontal plane. Okay. Determine the necessary force to move the body along the plane if the force is applied at an angle of 45 degrees to the horizontal with a coefficient of friction 0.24. So first what I will do is I will convert this particular statements into a diagram. That there is a body lying on a horizontal plane. So I will make a horizontal plane first. And let us say this is a body which is lying on this horizontal plane. And the weight for this is 1000 newtons. And in the question, it is also given that there is a force applied at angle 45 degrees with the horizontal. So what I will do is I will make one horizontal line and I will make a force, let us say, of P acting at an angle of 45 degrees with the horizontal. And the next thing given to us is the coefficient of friction. So I will write it here. Mu is equal to 0.24. So this becomes our diagram under consideration for which we need to solve and find out the value of this force P required just to move the body along the plane. So starting with the free body diagram of the body under consideration. So what I will do is first I will make a body isolating it from all the surfaces. So this is the body under consideration now. And as we have discussed, we need to draw four forces. First is the applied force, then self-weight, then reaction from contact surface, and finally the friction force. So starting with the first force, that is the applied force. So as given in the figure, I will make an applied force as it is with a value P acting at an angle of 45 degrees with the horizon. Then second force we have to make is the self-weight at the center and vertically downwards. So this will be the force vertically downwards. And the weight given to us of the body is 1000 newtons. So 1000. Then the third force which we make is the reaction from contact surfaces. Now, if you observe in the diagram, this body of 1000 Newton is in contact with this particular surface. Now, as the surface is horizontal, the reaction will be vertical because it should be perpendicular to the surface. And the direction of the force or the reactive force should be from surface to the body, as surface is offering the reaction. So it was always from surface to the body. So it will be like this. So transferring this force on the free body diagram, so I will make a normal force in this direction. And let us say the name I am giving is N1. The last force which you make in the free body diagram is the friction force. Now it is obvious that if I apply this force P in the direction right side, the body will move towards right. And as the direction of motion is towards right side, the friction force will act towards left side. So I will make a friction force toward left side here. And the value will be mu, that is 0.24 multiplied by reaction at that surface, so N. So this completes our free body diagram. Now to solve this problem by applying the conditions of equilibrium, we first need to resolve all the inclined forces. So we can see that this force P is inclined. So what I will do is I will resolve it by making one line parallel to x-axis and one line parallel to y-axis. The directions will be like this due to the force applied in this direction. So this component will be P cos 45 and this component will be P sin 45. So now our free body diagram is ready to be applied for conditions of equilibrium. So if I write the first condition, I will get summation of Fx should be 0. That is adding all the forces in x direction. So I will get this one. So I will write P cos 45 towards right side, so positive. Then we have left side minus 0.24 N1. Then we have ZZ. So there are only two forces in x direction, P cos 45 and 0.24 N1. So this all should be equal to 0. Now, because there is only this one equation and there are two unknowns, what I will do is I will just name it as equation number 1 and leave the equation as it is. Then we will apply the second condition of equilibrium, that is summation of Fy should be 0. So when I apply this condition, I will get from the diagram part, I will get P sine 45 because it is going upwards, so positive. Then I will get plus N1 and then minus 1000 is equal to 0. Now if I just rearrange this equation in the standard form, that is P sine 45 plus N1 is equal to 1000. And let this be equation number 4. Now what is the observation? Observation is there are two unknowns, that is P and N1. And there are two equations, 1 and 2. So there are two equations and two unknowns. So we can directly solve in calc. And I will get the answer for P as 273.18 newtons. And the value of N1 as 806.45 newtons. In the question it was asked to determine the necessary force P. So the answer is the necessary force P, which is required to move the block, is 273.18 newtons. And this completes the question of 4 marks. So what is the observation? The observation is, for any problem on friction, what you need to do is just draw the free body diagram properly and apply the condition Fx is equal to 0 and Fy is equal to 0. That's it. So only two conditions and you will get the answers. So most important thing, you have to concentrate more on drawing the free body diagram and then just apply the conditions of equilibrium Fx equal to 0 and Fy is equal to 0 to get the required answer. So hope you have understood this problem. And let us now proceed to the next problem, which says this. A block rests on a rough inclined plane, making an angle 30 degrees with the horizontal. Okay. The coefficient of static friction between the block and the plane is 0.8. Okay. If the frictional force on the block, directly we are given with the frictional force here now. So the frictional force, the block is given as 10 Newton. Find the mass of the block in the kg. So whatever may be the case, the first thing in any problem of friction will be to draw the free body diagram. So starting with the free body diagram part, the body first. So this is the body isolated from all the surfaces. Then the first thing to show is the applied force. So in the diagram, you can see that there is no applied force acting on the body. So there is no applied force, so we don't need to show the applied force. The next thing which we show is the self-weight, and self-weight to be shown vertically downwards. So I will show it vertically downwards, and I am showing it as self-weight. Please note this point. I am not showing it as mass M. I am showing it as weight W. The units will be in newtons. The third force which we show is the reaction force. Now, in the diagram, you can see that the surface on which this block is resting is like this. So as the surface is inclined, the reaction will be like this, because the reaction should be perpendicular to the surface. And because surface is offering the reaction, it will be from surface to the body. So if I just translate this force here, so this is the force, and I will name it as N1. Now, the last force, that is the friction force. And friction force to be shown opposite to the motion of the body. Now, just by logical observation of the diagram, as the body is kept on an inclined plane, this body will try to move down the plane because of gravity. Now, because it is moving down or will try or is on the verge of moving down the plane, the friction force will be up the plane. And the value will be mu multiplied by N1. And this value, the value of friction force, is already given to us in the question as 10 mu. So I will write it here only, that mu into N1, the complete value of mu into N1 is 10 newtons. So now we have completed the free body diagram of the given object. Now, next is to resolve the inclined forces. So to resolve the inclined forces, what I will do is, I will just change my reference axis to orientation of reference axis. Like, I will assume that this inclined line is X and this particular axis will be Y. So on the basis of this particular orientation, the weight W is now the inclined force. So what I will do is, I will resolve this inclined force, draw one line parallel to X and draw one line parallel to Y. By drawing this, then regarding the angle made by the surface here, as shown in the diagram, the angle made by the surface here, 30 degree, will be made 30 degree from this particular side. Just remember this, because it is a vertical force, the angle will always be from vertical. The same angle, the angle of plane will be made here with respect to vertical force. Now, because, again I repeat, because this is the vertical force, the angle 30 will be shown from the vertical component. Now, because this is 30 degrees, so this will be component as W cos 30, and this will be termed as W sin 30. Now, if I apply just one condition of equilibrium, that is summation of Fx equal to 0, what I will get from here is W sin 30 minus, because it is going towards left side, plus mu multiplied by N1, this should be equal to 0 because there is no other force in x direction. Now, from the question, we are given the value for this particular term. So I will just substitute it. So I will get minus W sin 30 plus 10 is equal to 0. Or I will get, therefore, W is equal to 10 divided by sin 30. Or finally, I will get, therefore, W is equal to 20 newtons. So I got the weight of the block as 20 newtons, but if you see the question properly, it is asked to us to find the mass of the block. So what I will do is, I will write mass is equal to weight divided by G. Because by default, we know that weight is m into G. So I am just rearranging the equation as mass is equal to weight divided by G. So weight we just now calculated as 20 Newton, divided by G is a universal constant, that is constant of acceleration due to gravity. So that is 9.81. So 20 divided by 9.81, if I calculate, I will get answer as 2.03 kgs. So my final answer, as required in the question, to determine the mass of the block in kg, so I will write mass is 2.03 kgs. That's it. And this completes the question of 5 minutes. So you have seen that how easy it is to solve the problems on friction. You just need to draw the free body diagram correctly and just apply the conditions of equilibrium based on the requirements. So here the requirement was only to find out mass, hence I have written the equation of only summation of Fx. If it would have been asked to find out the normal reaction also, N1, I would have used Fy also to find out value of N1. But that was not the requirement of the question. Hence, I stopped my calculation by applying only Fx equal to 0 and I got the required answer. With the hope that you all are enjoying the sessions, I will now move towards the next question, which says that a body or a block of 1000 Newton is placed on an inclined surface 30 degrees to the horizontal determine the force required. That means we are required to find out this force P to prevent. That is the important part. This is the most important part of the topic, which the student makes the mistake. Find the force required to prevent the sliding of the block down the plane. This is the most important part of the question. What is the scenario? Just imagine there is a block kept on an inclined plane and it is trying to move down the plane. And to just stop it, to just bring the block into an equilibrium condition, I am applying this force P. So what mistake students do in the exam is they don't read the question. They just see the diagram and see that because the force applied P is in the right side, hence the friction force will be towards downside the plane. That will be the wrong concept. Here we have to see that it is asked in the question, we have to find the force P such that we have to prevent the block down the plane. That means the crux of this question is the block is moving down the plane, hence the friction force will be up the plane. That was the most important part of this particular question. Now, coming to our regular discussion. So to solve any problem of friction, the first step is to draw the free body diagram. So I will make the body free from all the surfaces. The first force which we show is the applied force. So applied force is P. So P will be here. Then self weight to be shown vertically downwards. So vertical downward force, and the value is given as 1000 Newton. So 1000 here. Then reaction from contact surface. Reaction from contact surface. Now, if you observe from the diagram, the surface is like this, inclined. And so the reaction should be perpendicular to the surface and from surface to the body. So I will just transfer this in the free body diagram. So the reaction will be like this. The reactive force perpendicular to plane and from surface to the body, and it will be named as, let us say, N1. And the last force which we are going to show is the friction force. So as discussed while reading the question, the block is trying to move down the plane, hence the friction force will be up the plane. And the coefficient of friction is given as 0.15. So it will be 0.15 N1. This was the most critical part of the question. Normally, students make the mistake that because P is applied towards right side, they make friction force towards left side and the entire problem goes wrong. Now, this completes the free body diagram. Now, to apply conditions of equilibrium, all the forces should be either X or Y. So what I will do is I will change the orientation of axis and I will tell that this is considered to be as X and this is considered to be as Y. Now, from this orientation, the only inclined force is this force W. So I will just resolve it. Draw one line parallel to X, one line parallel to Y, directions of the force. And earlier it was discussed that because the force is vertical, the angle is also shown from vertical. So this is angle 30 degrees. The angle made by the plane 30 degree will be shown here as the angle made by the vertical component of the force. Now, once the angle is known, so now I will write this as 1000 cos 30 and this will be 1000 sin 30. So now our free body diagram is ready to be applied for condition of equilibrium. So the first condition of equilibrium we are writing as summation of Fx is equal to 0. So what I will get is the force is P going right side, so positive. Then there is friction force plus 0.15 N1, again it is going towards right side. And then the left side force is minus 1000 sin 30. All should be equal to 0. Now just converting this into a standard form, I will get P plus 0.15 N1 is equal to 1000 sin 30. Let this be equation number 1. Because there are two unknowns, we will not get the answer. Then, applying the other condition of equilibrium, that is summation of Fy should be 0. So for that, add all the forces in y direction. So I have N1 which is going upward. So I will write N1. Then there is 1000 cos 40 which is going downward. So minus 1000 cos 30. And there is no other force in y, so this will be equal to 0. So from here you can observe that there is only one unknown, N1. So I can get the answer directly. So I will write N1 is equal to 1000 cos 30. On solving it, I will get the value of N1 as 866.02 meters. And once I got N1, I will just substitute this value of N1 in this particular equation. So I will get as P plus 0.15. In place of N1, I will write 866.02. This should be equal to 1000 sine 30. On solving this equation, I will get answer for P as 370.09 meters. And this completes the solution to the problem. The question asked was find the force P required to prevent the block. So answer will be the force P required to prevent the block is 370.09. So again, if you might have observed, what I have done is I have just drawn the free body diagram and applied the conditions of equilibrium, Fx equal to 0 and Fy equal to 0 to get the required. Proceeding further, the next question. It says that a block of weight 500 Newton just starts moving down a rough inclined plane. Again, here it is mentioned that block is moving down an inclined plane at an angle of 30 degrees with respect to horizontal, when supported by a force of 200 Newton acting parallel to the plane in upward direction. Find the coefficient of friction. So here mu is required between the inclined plane and the block. Okay. So the first step, what we do is to draw the free body diagram. So starting with the free body diagram of this particular block. So I will make this block free from all the surfaces. So it will be like this. A block is free from all surface. Then showing the forces, first is the applied force. So applied force is shown as it is, 200 Newton. Then self weight to be shown vertically downwards, and the value is given to us as 500. Then reaction from contact surfaces. The surface is inclined. So because the surface is inclined like this, the reaction perpendicular will be like this, and should be from surface to the body. So it will be like this. Converting or the transferring the force in the free body diagram, I will get N was like this. So this is N1, the reactive force from the surface. And the last one, we have to draw free body diagram. Again, just be cautious that it is given in the question, the block is moving down the plane. So because block is moving down the plane, the friction force will be going up the plane. And the value will be, mu is not given, so I will write mu and n. That's it. So this completes the free body diagram of the given body. Now, to apply conditions of equilibrium, everything should be resolved into x and y direction. So I will consider again the coordinate system as x and y like this. And because it is considered like this, the only inclined force is this one, 500 Newton force. So drawing one line parallel to x and one line parallel to y axis, and one line parallel to y axis. Angle as we have mentioned, because it is vertical force, angle will be shown from the vertical 30 degree. So this will be 500 cos 30 and this will be 500 sin 30. Now we are ready to apply conditions of equilibrium. So the first condition is summation of Fx equal to 0. That is, add all the forces in x direction. So I will have the first force, let us say 200 going right side, then plus mu into N1 again going right side, minus 500 sine 30. This all should be equal to 0. So So just rearranging the terms, I will get mu into N1 is equal to 500 sine 30 minus 200. Let this be equation number 1. Now, when I apply summation of Fy should be 0. So for summation of Fy 0, we will get N1, then minus 500 cos 30 should be 0. So from here, I will get answer for N1 directly. I will get N1 is equal to 500 cos 30, which comes out to be 433.01 newtons. So once the value of N1 is known, I will just substitute this N1 in this particular equation. Here. So I will get mu multiplied by N1, that is 433.01, is equal to 500 sine 30 minus 200. On solving this particular equation, I will get the value of mu as 0.11. This completes the solution. So as it was asked in the question, to determine the value of coefficient of friction between the inclined plane and block, so the answer is mu is equal to 0.11. Okay, let us proceed to the next question, which says a block of weight 800 Newton is acted upon by a horizontal force P as shown in the figure. If mu s is equal to 0.35 and mu k is equal to 0.25, determine the value of P for impending motion up the plane. Again, very important part. The question asked here is to find out the value of P such that it is impending motion. Impending motion means the motion is just about to start. And now, because the motion has not started, that is, the body is not in motion, it is just impending. That means we have to use mu s in our equation. Generally, what students do is, because the motion is there, they read this word motion and they use mu k in the solutions. That is the wrong thing, because in friction we are considering that the motion is just about to start. It is just impending motion, that is, body is still under static condition. And because the body is in the static condition, the mu s, that is coefficient of static friction, will be used in the calculation part. This was the main part in this particular question. Now, starting with the free body diagram, so I will make the free body diagram, isolate the body from all the surfaces, then applied force as it is. So making the force P as given in the question in the perfect horizontal direction. So this is P. Then self weight perfectly vertical direction, and the value is given as 800. Then reaction at contact surfaces. Here also the surface is inclined, so reaction will be like this, which is perpendicular and from surface to the body. So transferring it to the free body diagram, so I will write here or make here the value as N1, reaction from contact surface. And the last one is friction force, as it is given impending motion up the plane, hence the friction force will be down the plane, and value will be mu s, that is 0.35 into N1. The last part, this completes our free body diagram. Now, to apply condition of equilibrium, all the forces should be resolved. That should be either in x or y. So if I consider this as my coordinate systems, x and y, there are now two inclined forces. The first inclined forces is this one, the weight. So here the resolution will be like this: force parallel to x and parallel to y. Then we have already discussed about this. As the force is vertical, the angle will be vertical here, that is 25 degrees. So this will be 800 cos 25 and this will be sine 20. Now regarding P, this inclined force with respect to this coordinate system. So I have to resolve this also. So I will draw one line parallel to X like this and one line parallel to Y like this. Now angle, because this force is horizontal, the angle will mark from the horizontal. So this angle will now be 25. Now because this is 25, this will be P cos 25 and this will be P sine 25. So all the resolution part is done. Now we can apply conditions of equilibrium. So for first condition, I will write summation of Fx should be 0. Fx equal to 0. So add all the forces in the x direction. So the first force going into x direction is P cos 25. Then we have the force which is going downward, that is minus 0.35 N1. And one more force going left side. So minus 800 sine 25 is equal to 0. So if I just rearrange the term, I will get P cos 25 minus 0.35 N1 is equal to 800 sine 25. Let this be equation number 1. Now applying summation of Fy equal to 0. That is, add all the forces in y direction, for which I will get N1 minus 800 cos 25 minus P sine 25 is equal to 0. Just rearranging the terms, I will get minus P sine 25 plus N1 is equal to 800 cos 20. Let this be equation number. Now if you just observe equation number 1 and 2, there are two unknowns, that is P and N1, and here also it is P and N1. So two equations and two unknowns, just put in your calculators and you will get answers, solve it simultaneously, and you will get answer for P as 780.4 newtons and N1 as 054.85 newtons. So as per the question, it was asked to us to determine the value of P, that is impending motion up the plane. So the answer will be the value of P to start motion up the plane is 780.4 newtons. And this completes the solution. This part, we have completed the topic 1 of the friction, that is block resting on a horizontal plane and block resting over an inclined plane. In further classes, we will start with the topic, you can say the subtopic, wherein the blocks will be connected to each other by means of thread or something. And the third part will be the blocks over one another, one block kept over another. So these are the cases we will study in the future classes. Okay, thank you.